Hello all, I am Dr. Praveen Baspe, Assistant Professor in the School of Civil and Environmental Sciences, JSP University, Pune. Today we are going to talk about the Sieve analysis of the coarse aggregate. So what is meant by the aggregates? So aggregates are the inert material which are the part of the concrete. So aggregates occupy around 3/4 of the concrete volume. So in today's lecture we are talking about the Sieve analysis of the coarse aggregate. So what is meaning of the coarse aggregate? So if you look up for the aggregates, there are two types of aggregate. One is fine aggregate and second is coarse aggregate. So how to differentiate between them? So the important size is 4.7 mm. So aggregates whose size is more than 4.75 mm, they are classified as the coarse aggregate, while the size lesser than the 4.75 mm is classified as the fine aggregates. So now how to get the well graded coarse aggregate? Because we know in the concrete we need to have compactness or the packing of the all the voids. So to ensure that we need to have the various classes of the aggregates so that the voids will be filled properly. So now I talk about what are the sizes required for the experiments. So in this particular experiment we are going to take different sieves. First one is 80 mm, then 40 mm, then 20 mm, then 10 mm, and last one is 4.75 mm. So we are going to use 5 digital sieves. We know that the aggregate can pass through the larger size sieve to the smaller size sieve. So the arrangement is in the similar manner. So now we will perform the experiments and see how we can do it in a practical mode. So this is the weighing machine where we can use it for the weighing of the aggregates. So now we will take first care weight of this container. So you will see now it's about 1 kilogram, 130 gram. So we will make it 0. Now for these experiments we are going to take 5 kgs of coarse aggregates. So now I will pour these aggregates. So it's better to have exact value so that it will be useful while calculation. So now we are having 5 kg of the coarse aggregates. So now we are going to do different sieve. Let me show the one of the sieve here. So this is 80 mm sieve, and you will see the size is written here. So this is IS certified sieves as per the IS standards, and the size is written here. So now I am going to mount all the required sieves in the same table. First, what we do? We need to tight it so that it will not fall down. Now we have to fix the sieves on this stick table. So what I will do first, I will put the pan, then 4.75 mm sieve. On the top of that I will fix 10 mm sieve, then 20 mm and 40 mm, and on top it's a 80 mm sieve. Now we are going to pour these aggregates in the sieve. So for the safety purpose, we need to close the lid of this sieve so that none of the material which falls outside the sieve. Now we need to lock with all this so that sieve cable can work properly. So let's start now sieve shaker. So here you will see we have different readings from 0, 10, 20 up to 30. So we are going to start it now. Now, after running it for the few minutes, we are going to lose this packing and will remove all the sieves. So I just tighten this so that it will not fall down on the sieves. So I will just remove. So now you will see, first I will remove the lid, then I will remove the 80 mm sieve. So you will see there is none of the aggregate is in the 80 mm sieve. Even though in 40 mm we will not find the aggregates. So it's in the 20 mm, we will see lot of aggregates are there. So now we are going to take the weight. So you have to ensure that the tear weight of this particular container is 0. Now I am going to pour the aggregates in the 20 mm sieve. Make sure that all of the aggregates in the 20 mm sieve are poured into the plain bridge. Now we'll record. Now I will keep it aside and measure the aggregates in the next sieve. So now we are going to measure the weight retained on the 10 mm sieve. So here now we are getting 2 kg 26 grams of the aggregates retained on the 20 mm sieve. Now we'll move on to the weighing coarse aggregate retained on the next sieve. So I just pour this remaining one. So this is the last sieve. You will see the aggregate amount is very less. So it's a 4.75 mm sieve. So now we are going to weigh it. So it is about 61 gram. So I'll keep it aside. Now we are going to measure whatever remainings of the aggregate are there in the pan. So it's a 41 gram. So there are smaller particles, so dust is there. So it is weighing about. So these particles are the lesser, having size of less than 4.75 mm. So now we have finished all the readings. Now we will go to the calculation part.
Start.
So in this particular table you will see weight of the coarse aggregate taken is 5 kgs, and we are going recorded the results of weight returned. So total should be 5 kgs because we are also using pan. So it will take care of the whatever smaller size particles are there which are having size lesser than the 4.75 mm. Now we are going to calculate the percent retained and cumulative percent retained, also percentage passed. So now here you will see in this table the readings are given. So we fell short of 28 grams which we have adjusted here in the 20 mm sieve, because we found that while pouring the aggregates in the 20 mm sieve, so some of the aggregates will fall down. So we are adjusted that 28 grams in this particular reading, and you will see we have also calculated the percentage retained, which is C3 by WC multiplied by 100, and WC is the weight of coarse aggregate taken, which is 5 kg. Similarly, we also calculated the cumulative percentage retained and percentage passed. So finally, we have calculated the sum of the cumulative percentage retained, which is summation of Sieve. So which comes about 254.58, and then we are going to calculate the fineness modulus, which is equal to the summation of Sieve divided by 100 plus 5, and which comes around 7.546. So of 20 mm aggregate having fineness modulus of 6.5 to 7.5. So through this result you will also get to know that the percentage retained on the 20 mm sieve is higher than any other sieves. So it will show that results are in the range, and the fineness modulus is the index which are going to use to describe the average size of the aggregate. So if you have coarser aggregates, it means that there is a lesser water demand and good workability while using it in the concrete. Thank you.